Come back. So this is problem 11. What we have here is called piecewise defined function. Function defined in pieces. Okay. When x is less than -1, the piece is 2 minus x. When x is between -1 and 1, the piece is x. When x is greater than or equal to 1, the piece is this. So that is, you have what is called a piecewise defined function. Okay, so let me explain in case piecewise defined function. Okay, so function is defined in pieces. Okay, so when x is less than -1, your function is 2 minus x. That is, y is 2 minus x. You know this is a line. Okay, so for a line, all you need are 2 points. When x is -1, I'm using that, -1, y is 3. When x is 0, y is 2. All I need are 2 points to draw the line. So what am I going to do with this entire line? I don't need an entire line. I just need that part when x is less than -1. So when x is less than -1, I am on the left. So this piece is what I need when x is less than -1. So to the left of -1, I took that piece of the line and stuck it here. Notice this piece ends in a hole because x is not equal -1, it's less than. Okay, so I took this line, cut it over here, and took the left piece because that's of interest to me, with a hole over here. All right, that got me this. Now what happens between -1 and 1? The piece is y equals x. Between -1 and 1, y is x. So if x is -1, y is -1. If x is 1, y is 1. Join the line because this is also a linear function. It's line. So between -1 and 1, I need this piece. All right. So notice what I do. I take that piece and stick it here. Here is filled in. Here is open. Why is that the case? Look at that. X is filled in. X is equal -1. So that point gets filled in. X is not equal 1. So that point is open. The third piece in question is a parabola, x minus 1 quantity squared. That's a parabola, right? Y equals x squared is a parabola at 0 with vertex 0. This is x minus 1, so it's shifted right. So that's the point. That's the parabola. Now I want this parabola starting 1 onwards, when x is 1 onwards. So starting from here, going up. So starting from here, going up. So notice this piece is filled in. So this piece is filled in. So this is your graph. This is your piecewise defined graph. Where do you think they are broken? When x is -1, there is a break. When x is 1, there is a break. Why is there a break at these points? Left hand limit here is 3. Right hand limit here is -1. That is, the two limits do not agree. Likewise here at 1, the two limits do not agree. The left hand limit goes to +1. Right hand limit goes to -1. So at -1 and +1, the limits do not exist. Okay, so you want to find those values of a for which limit does not exist. One is -1, the other is +1. All right. Okay, next problem. Here is another piecewise defined function. Sorry. 3x cubed minus 2m. Well, we don't know what m is. So it's kind of difficult to draw these, but we can still play with them even if we cannot draw them, right? One question is, what is the limit x approaching -1 from the right? So -1 is where the function is cut into pieces. So when I'm coming to -1 from the right, that is, x should be to the right of -1. In other words, it's the second piece I'm looking at, because x greater than -1 is when you're to the right of it. So I'm looking at this function and I'm finding the limit, you see. So what do I do? -1 from the right. -1 from the right means my x is greater than -1. So this is the feature I'm going to use. So I'm going to plug in -1 where I see x. Okay. -1 squared. M is m. So that is equal 6 times 1, 6 plus 5m. So this limit is 6 plus 5m. Okay. Whereas x approaching -1 from the left, that is x is less than -1, that will be this story. Okay. So that is, oops, I'm sorry. Yeah, to the left, that is the first piece. So 3, -1 to the power 3 minus 2m. Okay. X is less. So that gives me, here notice -1 power 3, negative survives. So -3 minus 2m. Okay. That -1 times 3 is -3 and minus 2m. So here you have -3 minus 2m. Now find the value so that the left hand limit is equal to the right hand limit. Okay, so you want the left hand limit to be equal to right hand limit. So you want -3 minus 2m to be equal 6 plus 5m. I'm sorry, this should be an m, not x. Okay, so let me move the -2m there, and -3, let me move the 6 here, minus 6 equals 2m plus 5m. -9 equals 7m. Let's divide both sides by 7. You get negative fraction 9 over 7 to be equals m. So m should be -9 over 7. -9 over 7. All right. Next question. Guess the value of the limit if it exists by evaluating the function close to where the limit is to be done. Okay. Limit. So this is theoretically, it's something that we need to check for ourselves. I will take two values of x. So for example, I'll go to Desmos. Okay. So notice we need to use x in radian form. So make sure you're in radian. Okay. So I don't want degree, I want radian. So sine of, say we are getting close to 0. So let's say 0.0001, right? And I'm going to use the same amount and divide it by it, right? Okay, sine x over x. That gives me 1 when I'm here. So that's for the positive value. Let me get close to 0 from the negative side. So I'll put a negative there and a negative here, I still get 1. All right. So I'm guessing it is a 1. It is in fact true that the closer you get to 0, sin x over x limit will be 1. Okay. We will need to learn this. We will do so in class. Okay.